Good evening, everyone. All good. ठंड बढ़ते जा रहा है. ठीक है. So last class we started with climatology. We discussed about the basics. What is climatology? The atmosphere, the composition of atmosphere, and then structure of atmosphere. है ना, यहाँ तक बात हुआ था. So atmosphere is the gaseous layer surrounding the earth. It is held by the earth surface by gravitational force. So climatology is the study of this atmosphere, the characteristics of atmosphere and the various different phenomena associated with the atmosphere. So with respect to composition, we have nitrogen, oxygen, argon, carbon dioxide and various other noble gases and few other gases. Okay. So we discussed about their brief characteristics, so particularly carbon dioxide being greenhouse gas, as well as the water vapor also being greenhouse gas. So then the next topic is the structure of atmosphere, the difference between the different layers, homosphere, heterosphere, the layers within homosphere, the layers within heterosphere. So overall, सबसे नीचे वाला layer को क्या बोलते हैं? What do we call? Troposphere. Above that? Then mesosphere, then thermosphere, exosphere. Exosphere contains magnetosphere, thermosphere contains ionosphere. Homosphere up to 6 to 16 kilometers. Stratosphere up to tropopause to 50 kilometers. Mesosphere up to 80 kilometers. Thermosphere up to 500 to 700 kilometers. Exosphere till the edge of atmosphere. Okay. So ionosphere is between 80 to 600, 650 kilometers. So magnetosphere is made up of two belts, one at 3000, another one is 16,000 kilometers. Okay. Temperature decreases in troposphere, increases in stratosphere, decreases in mesosphere, then increases rapidly from thermosphere. Okay. So basic characteristics. Temperature increases in stratosphere because ozone layer, presence of ozone layer. So then we also discussed about Karman line, the line which is considered to be the edge of the air space, beyond which the outer space begins, which can be accessed by the spacecraft, satellites, all of this. ठीक है, यहाँ तक बात हुआ था. बताइए, any doubts? Yes? Convection. तो आज convection का बात करते हैं, अभी बात करते हैं. So you remind me then. Hygroscopic nuclei. What is a hygroscopic nuclei? Hygroscopic nuclei refers to the particles which are present in the air. Okay, these are the particles. These are, we can say, solid particles. They are so light that they are floating in the air. So these particles are capable of absorbing water, moisture content in the air. Whatever the moisture content which is there in the air, so that will accumulate around these particles. Such particles are called as hygroscopic nuclei. Example, dust particles. Dust particles, they are called as hygroscopic nuclei. So आगे थोड़ा सा और डिटेल में बात करेंगे. सो इन द टॉपिक ऑफ कंडेंसेशन, एवापोरेशन, प्रेसिपिटेशन इन दिस. So there you will understand the role of these hygroscopic nuclei, why it is important. तो इससे कैसे इम्पैक्ट होता है. So ये सब चीज़ें डिटेल में समझ आएगा. ठीक है, अभी के लिए इतना काफ़ी है. So these are the minute dust particles which are present in the atmosphere. Solifluction will not happen everywhere. Solifluction happens where there is too much of water accumulation in a particular place. Okay, the question is, so in Joshimath there's land subsidence is happening, you know. So why there's no solifluction over there? So solifluction happens where the water accumulates near to the surface area. Surface area के पास में accumulate होता है, it gets mixed with the mud and all. So land subsidence happens when the water starts to seep into the below the surface area. Surface area के नीचे जब seep in होने लगता है, lower layer it starts to become weaken, है ना? Lower layer starts to become weaken. If this is the surface area, okay, mountainous area में चलो ऐसे है surface area. So if more water starts to accumulate here, तो यहाँ पर जो mud है mix up होके यहाँ पर solifluction बनेगा. But here it is not the case. Somewhere the water is seeping in and it is weakening the subsurface area. This is below the surface. जब ये सब weaken हो गया तो कभी ना कभी so collapse होना ही है. It may result in landslide or land subsidence or earth flow, mud flow. Okay, mud flow छोड़ो, mud flow तो ऊपर से आएगा. Earth flow, all soil creep. These are all happens due to the seepage of water into the lower layers, or maybe the lower layer over a period of time has got weakened. So major reason would be trees हमने हटा दिया. So construction करते समय ठीक से नहीं किया है. So did not take enough precaution measures. Okay, that is the reason why the lower layer would weaken. ठीक है, actual reason behind the Joshimath landslide or the land subsidence we are yet to understand. तो अभी रिपोर्ट हुआ है ना, तो अभी तो बहुत करेंगे. तो न्यूज़पेपर वाले न्यूज़ वाले बहुत बोलेंगे, उनको तो पता भी नहीं होता है व्हाट इज लैंडस्लाइड एंड ऑल. तो वील हैव टू वेट फॉर सम टाइम. ओके, सो वी नीड टू वेट फॉर द रिपोर्ट फ्रॉम द जियोलॉजिकल सर्वे ऑफ इंडिया. जीएसआई का हो गया, आईएमडी का हो गया. सो उनका प्रॉपर एनालिसिस होगा तो तभी कुछ कह पाएंगे. ठीक है. यस, एनीथिंग एल्स? एनी अदर डाउट्स? So let's continue. किसके लिए? सबके लिए, सबके लिए. हाँ, सबके लिए. So we have covered till here. The next topic, insolation, heat budget and albedo. Insolation, heat budget and albedo. first. What is insolation? So have you heard of the term insolation? जो भी फिगर होगा आपको लिखते जाओ, कोई एक्स्ट्रा टाइम नहीं मिलेगा, नहीं लिखा तो आपका ही लॉस है. So this is our sun, मान लो बहुत दूर है. The radiation which comes from the sun first enters the earth's atmosphere. Okay, मान लो this is our earth's atmosphere and then below the surface. The sun's radiation coming from the sun's interior से generate होगा. What is the process generating this sun's radiation? Nuclear fusion reaction that generates a huge quantity of heat. The energy that travels in all the direction in the form of electromagnetic radiation. इसको बोलते हैं electromagnetic radiation. So this radiation, when it passes through the Earth's atmosphere, first it passes through the Earth's atmosphere, a part of it gets absorbed. थोड़ा सा absorb होता है. Okay, part of it gets absorbed, but most of it falls on the surface and is absorbed by the surface. So this part of the radiation which is incoming towards the Earth, it is the radiation incoming towards the Earth, right? That is incoming solar radiation is what we call it as insolation. Is that clear? The incoming solar radiation which enters the Earth's atmosphere then falls on the Earth's surface is what we call it as insolation. Insolation refers to incoming solar radiation. So what happens to this radiation when it enters the Earth's atmosphere and then falls on the surface? I told you part of it gets absorbed in the atmosphere. Only a part of it, only a minimum part of it gets absorbed in the atmosphere. So ये कौन सा part है? It is part of the high energy radiations. Okay, we have studied in the structure वाला topic में हमने पढ़ा था. The gamma rays, X rays, UV rays are absorbed. This part gets absorbed in the atmosphere. So this is a very minimal part and most of the other parts passes through the Earth's atmosphere and then falls on the surface. When it falls on the surface, most of it is absorbed by the surface. What do you mean by absorption? Absorption मतलब उसको पकड़ के रखता है. It will hold it. Most of it is absorbed by the surface. So whenever a surface absorbs heat or energy, whenever surface absorbs heat or energy, its temperature rises. उसका खुद का जो temperature था वो increase होते जाएगा. Whenever the temperature of a body increases, it will release its own radiation. It will release its own radiation. So this is outgoing radiation. मतलब पहले the surface was at a particular temperature, let's say that it is at a temperature of 20 degrees Celsius. It continuously absorbed the heat and now it became 30 degrees Celsius. And because of the increase in temperature, it will release its own radiation. Any body which is above absolute zero emits radiation. है ना, ये तो सुना ही होगा physics chemistry में, है ना, any body above absolute zero releases radiation. Now this radiation which is released by the surface is the outgoing radiation, which we call it as terrestrial radiation. What do you mean by terrestrial? Terrestrial का मतलब क्या है? It is Earth. Okay, Earth's own radiation. Earth का radiation is terrestrial. That is what we study in terrestrial planets. याद है? Earth-like planet. है ना? It is terrestrial radiation, which is the radiation of Earth. Earth की वजह से जो release हुआ है, that is called as terrestrial radiation. So now if you observe very closely, the radiation which is released, which fell on the surface of Earth, which is absorbed by the surface, is short wavelength. Wavelength इसका बहुत कम है, मतलब frequency ज़्यादा है. Okay, it is of short wavelength. Okay, from non-science background जो भी है, wavelength frequency छोड़ो, मतलब इसका energy content बहुत ज़्यादा रहता है. It is highly energetic. इसके अंदर energy ज़्यादा रहता है. Okay, that is what is wavelength, right? What do you mean by wavelength? The distance covered by one particular crest and trough, है ना, एक ऊपर से एक नीचे से जो wavelength होता है, that is what is wavelength. If you see this wavelength, it is very short, है ना, this wavelength is long. This is called as long wavelength, this is called as short wavelength. And there is a higher energy in the short wavelength. However, the energy content, energy intensity of this long wavelength is lower, थोड़ा सा कम है. So it absorbed the high energy short wave radiation and it released the low energy long wave radiation. It is called as long wave radiation. This radiation is called as terrestrial radiation. So now it is passing through the Earth's atmosphere. Before it goes into the space, it has to pass through the atmosphere, right? So but this atmosphere is kind of discriminatory. है ना, थोड़ा सा partial है. So मतलब ये जो incoming आया तो उसको तो जाने छोड़ दिया. Major part of it was left to pass through, but the outgoing को तो easily नहीं छोड़ेगा. First the atmosphere will absorb this radiation, then it will release it slowly. है ना, incoming को तो जाने दे दिया, चलो चलो जाओ. Outgoing के लिए तो it is not letting it go very easily. है ना, so whatever the radiation which is coming from Earth, it says रुक जाओ, बैठ जाओ थोड़ी देर, है ना, wait for some time, बहुत दिन के बाद में आए हो, है ना. So then it will make it pass through the atmosphere over a very long period of time. Then it will gradually release into the space. So basically it is holding this outgoing radiation for some period of time before releasing back into the space. Finally तो वो भी release हो जाएगा, but it will be released over a long period of time. That is what is outgoing radiation. What do we call this phenomena as? Greenhouse effect. इसी को ही हम बोलते हैं greenhouse effect. What is greenhouse effect? The Earth's atmosphere is almost transparent to the incoming radiation. However, it is opaque to the outgoing radiation. Transparent मतलब it will just let it pass through. Opaque is it will not let it pass through very easily. It will hold it for some period of time, then it will gradually release it slowly. So that is due to the presence of certain gases which are called as greenhouse gases. There are certain gases in the atmosphere which are called as greenhouse gases. For example, carbon dioxide, methane, water vapor, etc. Okay, there are many such gases which are capable of doing this. It will let the incoming radiation, insolation को तो जाने दे देता है, so it will let it just pass through, but outgoing will not be pass. It will not let it pass through very easily. It will hold it, it will absorb it for some period of time, then it will re-release it gradually. That phenomena is what we call it as the greenhouse effect. It is due to the presence of certain gases which we call it as greenhouse gases. So is greenhouse effect something bad? Yes. So everything is good up to certain limit, है ना. So in fact greenhouse effect नहीं है तो there would not have been any life on the surface of Earth. It is the greenhouse effect which is responsible for the evolution of life on the surface of Earth. Because the greenhouse effect ensures that there is a stable temperature on the surface of Earth. Daytime mein the surface receives a huge quantity of incoming radiation. However, night time there is no such radiation. All the radiation is lost by the surface very quickly. बहुत easily वो छोड़ देता है. The surface will not be able to hold on to it for a longer period of time. It will release it. But that heat is held by the atmosphere. इसको थोड़ा सा पकड़ के रखता है ना, इसीलिए थोड़ा सा night time में comparatively it is slightly warmer than if at all there is no greenhouse gases. इसके अंदर greenhouse gas नहीं है तो और बहुत ठंडा हो जाता. The night sky would have become, night atmosphere would have become very very cold, and that would not be good for the existence of life. It becomes too freezing conditions. So greenhouse effect तो चाहिए. It is required to ensure stable temperature around the atmosphere. So problem क्या हुआ है? The greenhouse gases have increased too much beyond the level required. वो तो हमने ही रिलीज किया. Most importantly, carbon dioxide. Huge quantity of carbon dioxide is released into the atmosphere by burning fossil fuels. Fossil fuels are the major source of carbon dioxide. तो उसके वजह से बहुत ज़्यादा कार्बन डाइऑक्साइड accumulate होते जा रहे. Okay, so बहुत ज़्यादा होते जा रहे. And that is causing the temperature rise. Okay, so why there is temperature rise? Because the outgoing radiation is held for longer duration. जितना ज़्यादा कार्बन डाइऑक्साइड है उतना देर के लिए उसको पकड़ के रखता है. So याद है Venus is the hottest planet because it has very high proportion of carbon dioxide. So ठीक है 95%. इंडिया मतलब अर्थ में तो इतना तो ज़्यादा नहीं है. There is not so much. अगर हाँ है तो it would not have been possible. Life would not have been possible here. So but still, even 1 or 2 degree rise in temperature is sufficient to cause huge impact on the surface of Earth. है ना? So इसीलिए ग्रीन हाउस इफेक्ट इस उसको थोड़ा सा विलन बना दिया, बट एक्चुअल विलन तो हम ही लोग हैं. है ना? We are the one who are releasing these excessive amount of greenhouse gases. So this is incoming radiation, that is outgoing terrestrial radiation. In between there is greenhouse effect due to the presence of greenhouse gas. Now, structure of the atmosphere में मैंने बताया था, the temperature decreases with increase in altitude in the troposphere. Why? Why from the surface? Because as we move in the atmosphere, we are moving closer to the sun, right? So पास में जाते जाते तो temperature increase होना चाहिए ना? Decrease क्यों होता है? So basically the source of heat for the atmosphere is not the sun but the surface. Heat कहाँ से आ रहा है atmosphere के लिए? From the surface. The heat is coming from the surface. It is the terrestrial radiation which heats up the atmosphere, not the incoming radiation. At least in the troposphere. Stratosphere में तो ठीक है UV radiation absorb हो जाता है. So thermosphere में भी ऐसे absorb हो जाता है. Normally जो troposphere में there is no such mechanism of heating up from the sun. It is the surface which is the source of heat. The source of heat is surface, that is terrestrial radiation. The lower atmosphere, the troposphere, gets heated up by the terrestrial radiation, not the insolation. Insolation के वजह से वो heat up नहीं होता है. जो भी high energy radiation है वो ऊपर ही absorb हो गया है. यहाँ पर कुछ absorb ही नहीं होता है. So the actual source of heat is surface. So surface मतलब source of heat से जितना दूर जाओ तो उतना तो temperature कम होते जाएगा, right? The farther you move away from the source of heat, the temperature is less. So that is why with increase in altitude the temperature decreases. So there is a average rate of decrease of temperature, that is 6.5 degrees Celsius per kilometer. मतलब 1 किलोमीटर ऊपर जाओ आपका टेम्परेचर मतलब एटमॉस्फेयर का टेम्परेचर डिक्रीज होता है 6.5 डिग्री सेल्सियस. एक और किलोमीटर ऊपर जाओ so or 6.5 degrees on an average. On an average, the decrease in temperature in the atmosphere is 6.5 degrees Celsius per 1 kilometer. That is because you are moving away from the source of heat. This rate of decrease of temperature in the atmosphere is called as normal lapse rate. It is called as normal lapse rate. It's called as NLR. So normal lapse rate is due to the phenomena that the atmosphere gets heated by the surface, that is from terrestrial radiation, not from the insolation. Okay. So I told you the sun is continuously releasing the radiation in every direction, हर direction में तो release करता है, and only a part of it falls on the Earth's surface. Only a part of it falls on the Earth's surface. How much of it falls on the Earth's surface compared to the total proportion of radiation which is coming from the sun? Sun से जितना टोटली जितना आ रहा है उसमें कितना proportion अर्थ के, मतलब अर्थ को एंटर करता है, सरफेस छोड़ो, अर्थ को एंटर करता है, इंक्लूडिंग द एटमॉस्फेयर? एनी आइडिया? Less than 1%. Anything else? माइनस में कैसे हो गया? Any guesses? मतलब I'm saying from the sun, whatever the amount of energy released by overall by the sun, in that how much proportion falls into the area of earth, मतलब जो overall earth के तरफ से कितना आता है जो अर्थ का एटमॉस्फेयर को एंटर करता है? वो भी कम है, उससे भी कम है. Yes, 2 units in 1 billion. In 1 billion, just 2 units. That is the amount of sun's heat which comes to the earth's surface. You can imagine, उससे पूरा अर्थ का काम चल जाता है, पूरा अर्थ का काम चल जाता है. In that, even if you are able to trap a very minute part of it, हमारा काम चल जाता है. There's so much of potential in the solar energy. Okay, so even we are able to trap a very minute proportion of this. Human beings का जो जितना भी energy consumption है वो काफी, वो चल जाता है. So it's a huge quantity of heat and energy which is coming from the sun. So if you measure the amount of amount of energy which is received on the surface, मतलब on an average, if you take 1 centimeter square of area on the surface, you will receive 1.92 calories of energy per minute. Just 1 centimeter square area. In 1 centimeter square area, in 1 minute, 1.92 calories of energy is received from the sunlight. You can imagine the surface of earth कितना बड़ा हो सकता है, कितना energy आता है. So this is of course the average. This varies between the tropics and polar region. Tropics में ज़्यादा होता है energy intensity, polar region में कम होता है, and it also varies between aphelion and perihelion, right? थोड़ा सा तो variation होगा ही होगा. So this proportion is called as solar constant. इसको बोलते हैं solar constant. मतलब this much amount of energy is received on the surface. ठीक है? Any doubts? In the troposphere. NLR refers to troposphere only. Come again. You're asking why the earth is not emitting short wave radiation. See, the earth's surface will absorb all the wavelengths. I'm talking about the overall the average nature of the energy in that electromagnetic radiation. The overall nature of that energy is it is highly energy intensive. Okay, it is highly energy intensive. So because of that same reason that sun's temperature is very high. It is the sun's temperature which will decide the wavelength of the insolation, and earth's temperature which will decide the wavelength of outgoing radiation. अर्थ का टेम्परेचर तो बहुत कम है, जब सरफेस ऑब्जर्व करता है जो इनकमिंग रेडिएशन को, इट विल गेट स्प्रेड आउट, पूरा स्प्रेड आउट होगा, पूरा थोड़ा बहुत डिस्पर्स होगा, एंड इट विल रिलीज इट ग्रेजुअली. जितना इंटेंसिटी में वो रिसीव किया है उतना ही इंटेंसिटी में वो एमिट नहीं करेगा, वो ग्रेजुअली स्लोली रिलीज करता है. तो इसलिए दोनों का जो वेवलेंथ है या प्रॉपर्टीज है टोटली अलग है. इट ऑल डिपेंड्स अपॉन द टेम्परेचर ऑफ द सन एंड द अर्थ. Due to which frequency? That is depend upon the temperature of the source, right? Frequency of the radiation is depend upon the temperature of source. You are talking about the frequency or wavelength, both are same. Frequency कम है तो wavelength ज़्यादा है ना? wavelength कम है तो frequency ज़्यादा है, दोनों same ही है. Write about this. The amount of incoming solar radiation is called as insolation. Next point, the amount of insolation received by the earth is 2 billionth of solar energy. Next point, the amount of insolation received on the surface is equal to 1.92 calories per centimeter square per minute. calories per centimeter square per minute, called as solar constant. Next point, the incoming solar radiation is shorter in wavelength, stop. This radiation is absorbed by the Earth's surface and is re-emitted as long wavelength long wavelength terrestrial radiation, long wavelength terrestrial radiation. So next subheading, greenhouse effect. First point, the atmosphere is transparent to incoming solar radiation, incoming solar radiation, and is opaque to outgoing terrestrial radiation. Opaque to outgoing terrestrial radiation. Next point, the warming of Earth's atmosphere and its surface by the absorption of terrestrial radiation by some of the gases is called as greenhouse effect. Next point, the gases responsible are called as greenhouse gases. Examples: carbon dioxide, methane, nitrous oxide. Remember, nitrous oxide, not nitric oxide. Both are different. Nitrous oxide, hydrofluorocarbon, HFC, hydrofluorocarbon, perfluorocarbon, PFC, perfluorocarbon, sulfur hexafluoride, SF6, and water vapor. CFC is also a greenhouse gas, but the proportion of CFC has decreased drastically. बहुत कम हो गया thanks to the efforts from Montreal Protocol. ठीक है, so you will study about this in environment. So अभी के लिए ये 6 गैस as it is याद रखना इसी ऑर्डर में, it will be easier for you. आगे जाके काम के आएगा. because these are the 6 gases which are very important and are covered under Kyoto Protocol. Suna hai Kyoto Protocol? So it was earlier there before Paris Agreement came. अभी तो Paris Agreement का जो implementation में चल रहा है. So overall we are trying to fight the climate change by reducing the amount of greenhouse gases in the atmosphere. So in that these 6 gases are targeted. Okay, these 6 gases are very important. Water vapor को हम target नहीं कर सकते क्योंकि water vapor को target किया तो पूरा कहानी बदल जाएगा, है ना? So water vapor is required. ठीक है. Next point. The Earth's surface absorbs incoming solar radiation, and emits terrestrial radiation and hence it acts as source of heat. It acts as source of heat for atmosphere. Next point. Therefore, temperature decreases. With height. Temperature decreases with height at the rate of 6.5 degrees Celsius per kilometer. At the rate of 6.5 degrees Celsius per kilometer, which is called as normal lapse rate. It is called as normal lapse rate. So that is about insolation. So we know the basics. Source of heat for the atmosphere as well as surface is our sun. So we know the basic mechanism behind this, how the heat comes, how it falls on the surface, and how it is released into the atmosphere. So that is outgoing radiation is terrestrial radiation. There are different methods in which the heat transfer happens. Okay, this heat which is coming from the sun, it comes in one form, it is absorbed and it takes another form. There are different methods in which it moves from one form to another form. Okay, let's briefly study this methods of heat transfer. ये तो बहुत basics just to understand the other process, so we don't need to go in detail here. There are 4 basic methods of heat transfer: radiation, conduction, convection, advection. Okay, radiation, conduction, convection, advection. So non-science background जो भी है तो terms को as it is पहले याद रखो, then I'll briefly tell you the meaning of this and the mechanism involved. The first one is radiation, second one is conduction. Okay, you might have heard about conduct, conductor, conduction, that is the same conduction. Third one is convection. Convection तो मैंने बताया था troposphere में होता है, the continuous rising, the upward movement, that is convection. So advection is another type, so जिसका meaning बता दूंगा. So what exactly is radiation? Radiation का मतलब क्या है बताइए? What is radiation? Electromagnetic wave is a type of radiation. ठीक है. We just don't call the energy as radiation. Energy in motion is radiation. Energy in motion by itself. Okay, the transfer of energy from one part to another part without the need of any kind of medium, that is what is radiation. So what is radiation? Radiation is basically the energy is moving, energy is continuously moving from one place to another place without the help of any other medium. इसके लिए कोई medium जरूरी नहीं है. If there is a medium, then comes the others: conduction, convection, advection. So if the energy itself is moving from the source to destination, that is what is radiation. The moving energy is radiation. Best example is sun's radiation, solar's radiation, which is called as electromagnetic radiation. You know, the sun releases its energy heat, and that heat travels in all the direction. Does it require any medium for transportation? It just travels by itself. That is what is radiation. So what is conduction? So, सारा है conduction, convection, advection. तो conduction में convection में क्या difference है? So conduction is when there is transfer of heat from one body to another body through contact. One substance to another substance, one matter to another matter. है ना? So what exactly is radiation? What happens in conduction? Conduction, see, whatever the atoms and molecules which are present in this substance transfers the heat to the atoms and molecules in the other substance through vibration. है ना? So atoms and molecules which absorbs the energy, it starts to vibrate होके ये continuously ऐसे transfer करते हैं through contact, through touch. That is what is conduction. Transfer of heat or transfer of energy through contact from one substance to another substance is what we call it as conduction. Conduction. ठीक है? So what is convection? So मान लो यहाँ पर एक matter है, it has absorbed the heat, it has absorbed the energy. Now this, let's say this matter itself is moving, that too in an upward direction. That is what we call it as convection. When this matter, particularly the gaseous matter or even liquid matter also, liquid matter भी हो सकता है, when this matter absorbs heat and it is moving upwards, and transferring the heat from here to there. Okay, this is the source. यहाँ से वहां तक लेके जा रहे हैं. This transfer of heat from one layer to another layer by the movement of the matter itself. The matter itself is rising in upward direction. That is what is convection. इसको बोलते हैं convection. So advection क्या है? Convection ही है. अगर horizontal direction में हो रहा है तो that is called as advection. So what is happening in convection? The matter is moving in upward direction, the upward movement of matter, and through that it is transferring heat from here to here. Okay, पहले heat यहाँ पर था, अभी यहाँ पर आ गया क्योंकि the entire matter has moved from here to here. That is called as convection. The same movement of matter from one place to another place in the horizontal direction, and then it transfers the heat from here to here. That is called as advection. Advection. Okay, just to give you an example. Let's say there is a vessel, a container with water. Okay, मान लो हम सब मिलके कहीं पे ट्रिप में गए, ठीक है, और बॉनफायर लगा दिया इधर. कि मान लो फॉरेस्ट के अंदर बैठा है. अभी के लिए तो मानना ही पड़ेगा, ऐसे इमेजिन नहीं करना है, ठीक है. This is releasing radiation continuously. The heat released by this source is what we call it as radiation. This radiation is absorbed by this container. कि मान लो ऐसे यहां पर ऊपर से टांग के रखा है हमने तो मैगी बनाने के लिए, है ना. So it contains water. First this container will absorb this radiation because the radiation is continuously falling on this container. The water which is present in the container will absorb the heat from the container, or the container transfers the heat to the water through conduction. Wherever the water is in touch with the container, वहां पर heat transfer होता है. That is what is conduction. Now let's say यहां पर जो heat absorb हो रहा है, surface से absorb हो रहा है, that water gets heated up and it starts to rise in upward direction. You might have seen a container with boiling water. It always moves upwards, right? So that upward movement, the water itself is moving, right? The water itself is moving upwards. That is called as convection. Okay, this is conduction. So then this water rises and moves horizontally. ये तो ऊपर जाके ऐसे spread होगा ना. From here to here it is moving. The same water is moving from the center towards the sides. That is advection. ठीक है? So atmosphere has the same mechanism. The incoming light is in the form of radiation. The incoming light falls on the earth's surface. Now the surface gets heated up and the surface transfers this heat to the atmospheric layer. At the atmospheric layer, the surface absorbs the heat and then releases that heat to the atmospheric layer. At the zone of contact between the atmosphere, that is troposphere, and the surface, there is a transfer of heat through conduction. The air which is near to the surface absorbs the heat and this air itself rises and transfers the heat to the upper part of the troposphere. That is through convection. Sometimes from one part of the surface to another part of the surface, the heat exchange happens. There also the air is moving itself in horizontal direction. That is advection. Sometimes the ocean's water also gets heated up from one part to another part, and it moves from one part to another part in the form of ocean currents. Waves are different, currents are different. Ocean currents बोलते हैं उसको. ठीक है. These are the 4 methods of heat transfer. Any doubts here? ज्यादा डिटेल में जाने का जरूरी नहीं है, मतलब समझो काफी है. यस. रेडिएशन का सरफेस में, wherever it falls on the surface, there it gets absorbed. Absorption. Yes, it depends upon the type of surface, type of material. The absorption of solar radiation depends upon the type of material. Okay, right about this. Methods of heat transfer. Doesn't matter. Any kind of material, horizontal movement. First one, radiation. It involves transfer of heat in the form of radiant energy. Transfer of heat in the form of radiant energy. So stop. The incoming solar energy is in the form of electromagnetic radiation. the form of electromagnetic radiation. So next, conduction. It involves transfer of heat through molecular activity. Transfer of heat through molecular activity at the zone of contact. Full stop. It occurs at the zone of contact between troposphere and Earth's surface. Next, convection. Transfer of heat by vertical movement of mass of air. Vertical movement of mass of air. Example, convection of air along equator. Next, advection. Transfer of heat by horizontal movement of mass. Horizontal movement of mass. Example, planetary winds and ocean currents. ठीक है, दोनों के बारे में डिटेल में बात होगा, प्लानिटरी विंड्स के बारे में, ओशन करंट्स के बारे में. सो आगे आएगा. प्लानिटरी विंड्स आर बेसिकली विंड्स अक्रॉस द प्लैनेट विच आर देयर फ्रॉम वन लैटिट्यूड टू अनदर. ओशन करंट्स आर द कंटिन्यूस मूवमेंट ऑफ वाटर्स विद इन द ओशन. ओशन के अंदर ही कंटिन्यूसली देयर आर सर्टेन करंट्स. ठीक है, जस्ट गिव मी 2 minutes, I'll be back. So next, factors affecting insolation. Factors affecting insolation. So what was insolation? Incoming solar radiation. See, the overall amount of solar radiation emitted by the sun depends upon the factors which are present in the sun. Sun के अंदर जो reaction चलता है उसके ऊपर ही depend करता है. So but once this insolation leaves the sun's interior and passes through the sun's atmosphere and comes towards the earth. So there are few factors which will decide how much of insolation falls on the surface actually. So there is sun के through तो continuously insolation आ ही रहा है, and it falls on the earth. First passes through the atmosphere, then falls on the earth's surface. the amount of insolation received by the earth's surface at different latitudes and different regions, they are not same. It varies from one place to another place, one latitude to another, right? Why there is this difference? In some regions there is higher amount of insolation received, in another region there is lower amount of insolation received. What are the factors which will decide the amount of insolation which falls on the surface? Then एंगल ऑफ इंसिडेंस. एंगल ऑफ इंसिडेंस के बारे में हमने बात किया था, सीजन्स में बात किया था. एंगल ऑफ इंसिडेंस, लेंथ ऑफ द डे, सनस्पॉट, ठीक है वो भी है, बट वो तो वहीं पे डिसाइड कर देता है कि कीपिंग दैट कांस्टेंट. विजिबिलिटी ऑफ एटमॉस्फेयर, ट्रांसपेरेंसी ऑफ एटमॉस्फेयर वी कैन से. तीन मेजर फैक्टर है. ओके, तीन मेजर फैक्टर है. द इंसुलेशन फर्स्ट पासेस थ्रू द एटमॉस्फेयर. ओके, एटमॉस्फेयर में देयर मे बी वेरियस डिफरेंट क्लाउड्स. Clouds are capable of reflecting a part of it even without letting it pass through. थोड़ा सा तो वहीं से भी रिफ्लेक्ट कर देता है. So ज्यादा clouds है, so it will not let the sun's insolation to pass through. First factor is transparency of atmosphere. Transparency of atmosphere includes the factors like clouds, dust particles, or even water vapor for that matter, and few other particles which are present in the atmosphere that will decide how much of radiation will pass through the atmosphere. ठीक है, once it passes through the atmosphere, it will fall on the surface. Will it fall uniformly? No. The second factor is latitude. It is the latitude which will decide how much of insolation falls, because the latitude will decide the angle of incidence, right? At lower latitudes, the sunlight falls vertically and occupies smaller area. The amount of insolation received per unit area is more here than compared to the higher latitudes, where the amount of insolation received, the same amount of insolation gets spread over larger area and the unit area receives lesser amount of insolation. Okay, then you compare with the unit area here and here. Here it receives lesser amount of insolation than here, because the angle of incidence is decided by latitude. ठीक है. So near to the tropical region, the sun's light falls at higher angle, higher intensity of energy, higher amount of insolation received. Away from the tropical regions, the angle of incidence decreases, lower amount of insolation received per unit area. ठीक है. Within this region also, it varies from one season to another. Summer में the duration of the day is longer. Winters, the duration of day is shorter. The third factor is length of the day. That is depend upon the season. The day in which we are calculating, its length depends upon the seasons. फिर seasons depend upon the rotation, revolution, angle of incidence, the axis of rotation, the inclination in the axis of rotation. All of this वो वहाँ पर matter करता है. फाइनल इंपैक्ट क्या है? द लेंथ ऑफ द डे इज वेरिंग, एंड लेंथ ऑफ द डे वेरी होते ही तो ओवरऑल अमाउंट ऑफ इंसोलेशन रिसीव्ड विल वेरी. इट विल इंक्रीज और डिक्रीज. इन समर वी रिसीव वेरी हाई अमाउंट ऑफ इंसोलेशन, इन विंटर्स वेरी लो अमाउंट ऑफ इंसोलेशन. Three major factors which will decide how much of insolation is received on the surface. Write about this. How much of insolation received on the surface, वो उसका ही बात कर रहे हैं। इंसुलेशन रिसीव होने के बाद में कैसे होगा वो बाद में आएगा। इंसुलेशन टॉक्स अबाउट ओनली इनकमिंग रेडिएशन, राइट। फर्स्ट वन, transparency of atmosphere. Cloud cover, dust particles, water vapor, etc. reduces transparency of atmosphere and reduces insulation received, at the surface. Second, latitude. Latitude of a place. Decides the angle of incidence of insolation which affects insulation received per unit area of the surface. Example, along tropical regions, insulation falls vertically and is concentrated in small area. Along temperate and polar regions, angle of incidence is oblique and insulation is distributed over larger area. Oblique and insulation is distributed over larger area. Third, length of the day. Longer the day, more the insulation received. At the surface. So stop, length of the day depends on season. Yeah. कुछ डाउट्स है? What is energy? What energy? Radiant energy. तो बहुत अंदर जा रहे हो. ठीक है, अच्छी बात है, समझना चाहिए. Energy is what is generated at the core of sun. Energy is the thing which runs the universe. Energy and matter. The energy is the same energy which was released during the Big Bang. The same energy which was released during the Big Bang. Initially there was only energy. Gradually energy got converted into matter. E is equal to mc square. Now the same matter gets converted into energy. That is what is fusion reaction. The same energy has the capacity to travel by itself. इसके लिए कोई ज़रूरत नहीं है, कोई किसी का मदद नहीं चाहिए. In that form it is called as radiation. When it moves without the help of any medium. When a matter absorbs energy, the matter can move. When there is no matter, the energy itself moves. So that is what we call it as radiation, radiant energy. ठीक है. हीट बजट. बजट तो सुना ही होगा. बजट क्या होता है? बजट सुना है? अभी तो आएगा. So, क्या होता है बजट में? क्या होता है? What happens in a budget? क्यों क्यों करना है बजट? ठीक है, तो चलाने के लिए क्या चाहिए? That is not the idea of budget. The idea of budget is to keep the estimate proper. कितना आ रहा है, कितना जा रहा है, ये तो पता होना चाहिए ना. कितना इनकम आ रहा है, कहाँ पर कितना स्पेंड करना है. That is what is budget. ना गवर्नमेंट की तरफ से जो बजट अलोकेट होता है, सो दे विल से इतना सारा इनकम आ रहा है, इतने सारे सोर्सेस हैं, एंड इनकम कैसे होगा वो भी बताएंगे. ओके, तभी होता है टैक्स का बात. टैक्स कितना होगा ये सब तो बात करते हैं. द सेम टाइम दे विल ऑल्सो टॉक अबाउट ये सारा पैसा हम खर्चा कैसे करेंगे. ओके, सो इफ़ यू सी ऑन द डे ऑफ बजट तो पूरा फिगर देते. ओके, 1 रुपये में कितना पैसा कैसे आ रहा है, तो वही 1 रुपये कैसे कहाँ कहाँ पर जा रहे हैं. दैट इज व्हाट इज बजट. हीट बजट refers to the amount of management of heat, because the earth continuously receives the heat from the sun, है ना. This heat is coming from the sun continuously. There is no holiday over sun. वहाँ पर तो कोई छुट्टी नहीं है ना. 24/7 365 days into billions. It continuously goes on. The heat is continuously released. It is released in all the direction. So अर्थ कहीं पे भी घूम के आए तो हर जगह में तो सन का रेडिएशन मिल ही जाता है. The entire 360 days, 365 days. So this heat is continuously falling on the earth's surface. So in any place, if the heat is continuously falling, if the heat is continuously being absorbed, the temperature of that particular part will start to increase. जितना भी माइन्यूट हो, इवन इफ इट इज ए वेरी फ्रैक्शन, ओके, फ्रैक्शन ऑफ ए कैलोरी, इवन इफ इट इज फॉलिंग कंटिन्यूसली 24/7 365 days, ऐसे एक ही जगह में गिरते जा रहे हैं तो कंटिन्यूसली वो हीट ऑब्जर्व करेगा एंड उसका टेम्परेचर तो बढ़ते जाएगा. ओवर ए लॉन्ग पीरियड ऑफ टाइम इट्स टेम्परेचर विल स्टार्ट टू इंक्रीज, राइट. सो वी नीड ए बैलेंस. We need a balance. जितना इनकमिंग आएगा उतना ही बाहर भी जाना है. Then only Earth will maintain its temperature, right? Earth is a huge surface. Imagine huge quantity of heat is continuously falling on this. And if it is not re-emitting in the same quantity, अगर 1% भी चेंज हो गया, अगर 1% भी कम हो गया या ज्यादा हो गया, बहुत ज्यादा वेरिएशन हो जाता है. जितना आ रहा है एग्जैक्टली उतना वापस भी जाना है. ओके, मान लो 100 यूनिट्स आ रहे, 100 यूनिट्स should be released back. Then only whatever the heat which is present on the surface of Earth, that will remain constant. The temperature remains constant. अगर मान लो 100 यूनिट्स आ रहे तो जैसे ह्यूमन बीइंग जैसे सोचते चलो 1 यूनिट पकड़ लेते, किसी को पता नहीं चलेगा. तो किसको पता चलेगा? 1 ही यूनिट है, 1 ही पैसा है या 1 ही रुपए है. If it releases 99, 1 unit starts to accumulate continuously over days, months and years. That heat will start to increase the temperature. 1 यूनिट भी वेरिएशन नहीं हो सकता है. या 1 यूनिट एक्स्ट्रा छोड़ दिया, चलो 100 आ गया, 101 दे देते हैं. So what is happening? 100 is continuously coming, 101 is continuously going. That means इसका खुद का जो heat loss हो रहा है, the heat which is there in the Earth's interior, that is continuously is losing, right? So gradually its temperature starts to decrease. दोनों नहीं हो सकता, it has to remain stable. So this calculation is what we call it as heat budget. It remains stable. That is what is the nature. That is what is the overall balance of nature. So it is very much required for the existence of life or the existence of this system as it is, the planetary system. So this calculation of incoming and outgoing radiation in terms of the budget is what we call it as heat budget. So कितना आ रहे उतना ही मतलब वापस as it is जाना चाहिए. So इसको ऐसे कौन करके रखा है पता नहीं. So who has made this system? Who has made this system? I'm asking. मतलब कौन है इसका responsible? नहीं ये तो I'm saying who is responsible for this balance? वही है the question of life. ठीक है, लिखो what is heat budget? On the global scale, the Earth must re-radiate. Earth must re-radiate as much heat back to space as it receives, as much heat back to space as it receives from the sun. From the sun. Stop. This is necessary. This is necessary in order to maintain a uniform temperature this is necessary in order to maintain a uniform temperature by the Earth. Stop. The gains and losses in heat by way of incoming solar radiation and outgoing terrestrial radiation is called as heat budget. वेव मतलब क्योंकि मैटर अलग है ना. Why insolation is different from terrestrial radiation? The matter which is emitting this is different. It is not like insolation को as it is वापस भेज रहे हैं. इंसुलेशन को पहले ऑब्जर्व करेंगे फिर वापस भेजेंगे, तो वहां पर सारा डिफरेंस होता है. सोलर प्लेज अलग कॉन्सेप्ट है, पहले इसको समझते हैं. So heat budget involves the different components of incoming and outgoing radiation. We need to remember these components. इस components को हमें as it is याद रखना है. Okay, we take a sample of 100 units, assuming 100 units are entering the earth. So according to heat budget, 100 units वापस भी जाना है. Right? If 100 units have entered the earth, 100 units should be released. So let's see what happens to these 100 units when it enters the earth. So whenever electromagnetic radiation, the sun's radiation, falls on a particular medium, whenever it falls on particular medium, okay, electromagnetic radiation छोड़ो, कोई भी wave का ही ले लो, any wave or any radiation, any kind of energy, when it falls on a particular medium, it can be solid, liquid, gas, anything, a part of it gets observed. Only a part of it gets observed because that depends upon what kind of medium it is. What is the nature of the medium? What exactly it is made up of? All of this will decide. A part of it gets reflected also. Okay, this is what we call it as reflection. This is absorption. Refraction जोड़ो, refraction में पास हो जाता है, उसको छोड़ा अभी के लिए. We are not talking about optics. When a radiation falls on a particular material, the material either absorbs or reflects. दो ऑप्शन है. What do you mean by reflection? उसको as it is वापस भेजना है. उसको as it is वापस भेजना है, without observing. Absorbing is holding it. है ना, it is holding it in the form of the energy in its own matter. That is what is absorption. This is what is incoming. Now, how much is reflected, how much is absorbed, that depends upon the nature of material. For example, if the radiation is falling on a mirror, it goes back as it is. If the same radiation is falling on, let's say, a dark surface, almost everything is absorbed, है ना? It depends upon the material, right? And that dark surface can be a land surface or water surface, है ना? अलग अलग nature का हो सकता है, अलग अलग material का हो सकता है. Then again it will decide how, in what way it will be absorbed, for how long it will be held, and how long it will be released back. वो released back अलग है. First it is absorbing or reflecting. Reflecting को क्या हो गया? Reflecting तो as it is वापस चला गया. What happens to this absorbed energy? Absorbed energy is held by this material for some duration of time and will be re-released. That is what we call as re-radiation. इसको बोलते हैं re-radiation. In the case of Earth, this is what is we call as terrestrial radiation. Terrestrial radiation is different. Terrestrial radiation is different with respect to reflection radiation. Okay, terrestrial radiation is different with respect to reflected radiation. Reflection तो as it is, जितना जैसे वापस आया था वैसा ही वापस गया. अगर short wave में आया, short wave में ही वापस जाएगा. There is no change in the nature of this. But terrestrial radiation is different because absorb करके re-release किया है ना. It has been absorbed and now the surface is really re-releasing through its own mechanism. That is what is terrestrial radiation. एक और part भी है. If the incoming radiation is passing through a gaseous matter like Earth's atmosphere, यहां पर भी थोड़ा सा absorb हो सकता है, यहां पर एक और फिनोमेना भी हो सकता है, दैट इज व्हाट वी कॉल इट एज स्कैटरिंग, बिकॉज देर मे बी सर्टेन पार्टिकल्स, माइन्यूट पार्टिकल्स इन द एयर विच विल डिफ्लेक्ट इट फ्रॉम इट्स पाथ, उसका ऐसे डिफ्लेक्ट कर देगा. स्कैटरिंग क्या होता है, व्हाट एग्जैक्टली स्कैटरिंग है ना, टू चेंज इट्स पाथ. ऐसे आ रहा था, ऐसे चेंज कर दिया. स्कैटरिंग से क्या होगा फाइनली, आइदर इट विल बी रिलीज्ड इनटू द स्पेस और इट विल बी सेंट बैक इन डिफरेंट डायरेक्शन एंड फाइनली ऑब्जर्व ही होगा. स्कैटरिंग इज काइंड ऑफ इंटरमीडिएट ओनली. स्कैटरिंग ऐसे आ रहा था, उसको चेंज कर दिया डायरेक्शन, वो डायरेक्शन चेंज होकर या वापस चले जाएगा या दूसरी जगह में जाके ऑब्जर्व हो जाएगा. So finally there are only two possibilities for the incoming radiation, either it gets observed or it gets reflected, right? So if there are 100 units, there are two paths these 100 units can take. One is absorption, second one is reflection. The 100 units which enters the earth includes both the atmosphere as well as surface. In that 65 units gets observed and 35 units gets reflected on an average. 65 यूनिट्स गेट्स ऑब्जर्व्ड, 35 यूनिट्स गेट्स रिफ्लेक्टेड. उसका मतलब है ये पहले ऑब्जर्व होके दोबारा रिलीज होगा, ये भी वापस चला जाएगा, बट पहले ऑब्जर्व होके दोबारा रिलीज होगा. दैट विल बी ए चेंज रेडिएशन, इट विल नॉट बी सेम एज द इनकमिंग रेडिएशन, बट दिस पार्ट इज रिफ्लेक्टेड एज इट इज. दैट मीन्स इट इज सेंट बैक एज इट इज इन इट्स ओरिजिनल फॉर्म, जैसे आया था वैसे ही वापस भेज दिया. दैट इज व्हाट इज रिफ्लेक्शन. रिफ्लेक्शन पार्ट, देयर आर 3 components. 27% is reflected, 27 units are reflected by clouds because that is the largest component of reflection. 2 parts are reflected by the surface and 6 parts are reflected through scattering. मैंने बताया था ना बीच में स्कैटरिंग होगा, स्कैटरिंग होके फाइनली आइदर रिफ्लेक्ट होगा या ऑब्जर्व होगा, सो दैट इज रिफ्लेक्शन थ्रू स्कैटरिंग. There are total of 35 parts. In that 35 parts, 27 parts are reflected by clouds. While passing through the atmosphere, it will fall on the clouds. Clouds being bright in nature, थोड़ा सा ऐसे ही वापस भेज देता है. And 2 parts will get reflected by the surface because surface में major part is totally dark in color. मतलब जितना ज्यादा डार्क होगा उतना ज्यादा ऑब्जर्प्शन रहेगा, जितना ज्यादा ब्राइट होगा उतना ज्यादा रिफ्लेक्शन होगा. Which part of the earth surface is capable of reflecting this? Ice caps, glaciers, polar regions, जहां पर बहुत ज्यादा स्नो सरफेस है. So that is why only 2% is reflected by the surface. सरफेस के ऊपर के गिरने के बाद भी वो रिफ्लेक्ट हो जाएगा. 6% is reflected through scattering. In this 65% which is observed by the earth as a whole, 51% is observed by the surface and 14% is observed by the atmosphere. ठीक है, this is by surface, this is by atmosphere. So what is happening? Let's say this is the atmosphere, this is the surface. If 100 units are entering the atmosphere, in that a part of it is reflected back by the clouds and through scattering, and after falling on the surface it goes back as it is. ये जो एज इट इज गया है ना, the part which has gone as it is same as the nature of the incoming radiation. अगर ये शॉर्ट वेव है तो ये भी शॉर्ट वेव ही होगा, ओके, इसके वजह से भी वापस चला गया. स्कैटरिंग की वजह से भी वापस चला गया. कितना चला गया? 35% चला गया. सो बचा कितना था? 65%. In that 65%, a part of it gets observed while passing through the atmosphere. That part of it is 14%. ये कहां पर होता है? Upper atmosphere. Gamma rays, X rays, UV rays. That all amounts to 14%. Rest everything falls on the Earth's surface, and this 51% is absorbed by the surface. ठीक है? Now, in this 51% which is absorbed by the surface will release all the 51. है ना? It has to release all the 51. It cannot hold on to any even one unit less, or it cannot release one unit more. 51 absorb किया था, 51 भी re-release कर देगा. What do we call this re-release radiation as? Terrestrial radiation. But in that terrestrial radiation अभी आएगा हमारा greenhouse effect. This re-release terrestrial radiation is going through the atmosphere. Because surface और space के बीच में तो एक layer है, gaseous layer है, atmosphere. It has to pass through the atmosphere. It cannot re-release back into the space directly. Here there are greenhouse gases which are capable of absorbing this outgoing radiation, but these gases will not be able to absorb 100% of this outgoing radiation. मतलब 51 वापस जा रहा है तो 51 में 51 को भी पूरा पकड़ नहीं पाएंगे. It will be able to absorb only 34. हो गया? In this 51, 34 is absorbed by the atmosphere. From this outgoing radiation, 34 is absorbed by the atmosphere. बचा कितना है? 17. 17 somehow escapes from the atmosphere and goes into the space. 17 is released into the space directly from the surface. Is that right? 17 is released into the space directly from the surface. It will escape the greenhouse gases. It will escape the atmosphere somehow. The atmosphere will be able to hold only this 34 of this outgoing terrestrial radiation. The atmosphere already had 14. Now it got 34 more. How much it is? 48. Now this 48 will be released gradually by the atmosphere into the space. The 48 will be released gradually, बहुत slowly उसको छोड़ता है. That will balance the heat budget. Balance हुआ है? एक बार चेक करते हैं. So what is the overall outgoing? 27 is reflected by clouds, 2 is reflected by the surface, and 6 is reflected by scattering. How much it is? 35. 17 is released by the surface into the space directly. 35 plus 17? 52. 52 plus 48? 100. 48 is released into the atmosphere, into the space by the atmosphere. Okay, these are the parts which are released into the space. वापस चला गया 100. This is what is heat budget. Okay, so जितना simplify करके बता सकता है उतना simplify करके बताया हूँ. So if you want to remember this, you can remember this, or there is also another figure from NCERT. You can follow that also. वो भी एक बार explain कर देता हूँ. रुक जाइए. So this is what is given in NCERT. यहाँ पर incoming and outgoing दोनों को अलग अलग कर दिया. So there is 100% incoming radiation. In that 27 is reflected by clouds, 2 is reflected by surface, and 6 is scattered to space. Scattering reflection. बचा कितना था? 65 है ना? In that 65, 34 plus 17, 51 is absorbed by the Earth's surface. 14 is absorbed by the atmosphere. So in that 51, 17 is re-radiated into the space directly, and atmosphere already had 14, and 34, this 34 is transferred to the atmosphere, and that 48 is released by the atmosphere into the space. Okay, so you can write this separately. ये नीचे वाला पार्ट छोड़ो, ये that explains how exactly the heat is transferred from the surface to the atmosphere. So पहले ये basics याद रखो, then you can remember that. कौन से? कोई दिक्कत नहीं, समझाना है बस. So this is what is heat budget. You have to remember the numbers exactly as it is. There would be a minor variation from one source to another in these numbers. 35, 34 थोड़ा सा variation है. So but this is given in NCERT. Let's follow this. आगे जो भी मैंने लिखा है वो NCERT का है, तो वही follow करते हैं. इसको as it is लिखना, मतलब as it is याद रखना है, and you have to remember each and every component. इसके ऊपर prelims का mains का दोनों का क्वेश्चन आ सकता है. In mains, what is heat budget? Explain the components of heat budget. Heat budget, heat balance, both are same. Okay, then you have to draw this flowchart and explain. अभी कोई डिक्टेशन नहीं रहेगा, पहले इसको याद रखो, वो काफी है. बाकी डिक्टेशन चाहिए तो मटेरियल में देख लेना. प्रीलिम्स का इंपॉर्टेंट पार्ट है. सो देयर दे मे आस्क यू स्टेटमेंट वाइज, स्टेटमेंट देके भी पूछ सकते हैं हाउ मच प्रोपोर्शन इज इनकमिंग आउटगोइंग, और दे मे गिव यू मल्टीपल कंपोनेंट्स एंड आस्क यू टू अरेंज देम इन इंक्रीजिंग और डिक्रीजिंग ऑर्डर. ओके, फॉर एग्जांपल ऑप्शन ए reflection by the surface, option B reflection by clouds, option C re-radiated by the surface to the space directly, option D scattering reflection. इनमें से अरेंज करो इंक्रीजिंग ऑर्डर डिक्रीजिंग ऑर्डर, ऐसे क्वेश्चन ऐसे आ सकते हैं. Okay, for that you have to remember this as it is. Okay, this is our heat budget. So write this and take a break and we'll continue after that. So that was about heat budget. Any doubts about heat budget? बताइए. Yes, obviously time का रोल तो होता ही है. So is the rule of time. ये जो इनकमिंग एंड आउटगोइंग है, इट इज द ओवरऑल बैलेंस. जितना आएगा उतना वापस तो जाएगा ही. आज नहीं तो कल, कल नहीं तो परसों, वापस तो जाना ही है. बट जो कल आया था वो आ जाएगा. ओवरऑल देयर इज अ बैलेंस, है ना. दैट इज वेरी मच रिक्वायर्ड. बट दिस इज बीइंग डिस्टर्ब नाउ. दैट इज कॉजिंग ग्लोबल वार्मिंग. Heat budget basically says that there is always a balance. The incoming radiation will be there. Some of it goes back as it is. Some of this will stay for some time and it will be released over a period of time. So, in between जितना देर के लिए रहेगा वो थोड़ा सा extend हो रहा है. In between, whatever the length of the stay it was having. So that is getting elongated. Why? The gases which are responsible for greenhouse effect, that has increased in between. है ना. So जितना पहले था उससे ज्यादा हो रहा है. Now due to the presence of more amount of gases, first of all more amount of heat is absorbed here. The heat which is being released into the space by the surface, उसमें ज़्यादा component absorb होगा and ज़्यादा देर के लिए भी वो रहेगा atmosphere में. Atmosphere will not release this immediately. So that disturbance is causing global warming. So global warming is when the outgoing is disturbed. Incoming is as it is. Outgoing is disturbed. Outgoing disturbed in the sense that outgoing is reduced. अगर outgoing reduce हो गया तो global warming होगा. अगर outgoing increase हो गया तो global cooling. यस, और इनकमिंग ही रिड्यूस हो गया तो आउटगोइंग एज इट इज है, इनकमिंग रिड्यूस हो गया तो राइट. सो हाउ इज दैट पॉसिबल? क्लाउड्स तो ज्यादा नहीं हो सकते, क्लाउड्स तो ज्यादा नहीं हो सकते, और कैसे हो सकते? ग्लेशियर्स मेल्ट होने से रिफ्लेक्शन कम होगा, अब्जॉर्प्शन ज्यादा होगा, उससे ग्लोबल वार्मिंग होगा. ग्लोबल कूलिंग कैसे होगा बताइए? वॉल्केनिक एरप्शन, ठीक है सुनाए, तो उससे कैसे होगा? डस्ट पार्टिकल्स, स्कैटरिंग रिफ्लेक्शन बढ़ जाएगा. ओके, क्लाउड्स रिफ्लेक्शन वाला तो ज्यादा इंक्रीज नहीं हो सकता है, देयर इज अ लिमिटेशन फॉर दैट, बट स्कैटरिंग रिफ्लेक्शन इंक्रीज हो सकता है ना, ड्यू टू द ह्यूज क्वांटिटी ऑफ डस्ट पार्टिकल्स रिलीज. सो व्हेनेवर देयर इज अ लार्ज स्केल वॉल्केनिक एरप्शन, it can result in both. It can result in global warming as well as global cooling. If it releases huge quantity of dust particles, it will reduce the incoming. Incoming को reduce करता है and it will result in global cooling. If it emits large quantity of carbon dioxide, methane, water vapor, which is also possible from a volcanic eruption, it will increase the greenhouse effect and causes global warming. दोनों हो सकता है, ठीक है. So any other doubts? It will not disturb. The usage of solar energy, will it disturb the heat budget? No, because energy can neither be created nor be destroyed. हम उसको पकड़ के यूज करके रिलीज कर देते हैं. Will not be using that energy as it is. फॉर्म चेंज होगा बट रिलीज तो हो ही जाएगा, उसको पकड़ के तो नहीं रख सकते हम. What happens when we observe the solar radiation through solar panels? सोलर पैनल में ऑब्जर्व करने से क्या होता है? उसको कन्वर्ट कर दे, है ना, इन डिफरेंट फॉर्म्स, एंड ग्रेजुअली वो जब स्पेंड करेंगे वो तो रिलीज हो ही जाएगा. उसको तो पकड़ के नहीं रख सकते, ठीक है. एनीथिंग एल्स? ठीक है. दिस व्हाट इज हीट बजट, ये बहुत इंपॉर्टेंट है, इसका टर्म्स आई होप यू गाइज रिमेंबर दिस. 100 इनकमिंग, रिफ्लेक्शन इज 35, absorption is 65. In the 35, reflection by clouds 27, reflection by surface 2%, and scattering reflection 6%. Absorption by the surface, absorption by the atmosphere, the amount re-radiated by the surface back to the space directly, transferred to atmosphere, amount released by the atmosphere into the space, that is what is heat budget. Next, albedo. Albedo. See, any surface, any kind of mass or material or surface for that matter, when it receives incoming radiation, I told you part of it is absorbed, part of it is reflected. रिफ्लेक्शन और ऑब्जर्वेशन में यही डिफरेंस है. अब्जॉर्प्शन में जो एनर्जी ऑब्जॉर्ब होगा वो तो एज इट इज पूरा एनर्जी इसमें मिक्स हो जाएगा, देन इट विल रिलीज इट्स ओन रेडिएशन, सो दैट विल बी द लॉन्ग वेव टेरेस्ट्रियल रेडिएशन. बट रिफ्लेक्शन पार्ट इज विदाउट अब्जॉर्प्शन, दैट एनर्जी इज सेंट बैक एज इट इज. शॉर्ट वेव में आया था, शॉर्ट वेव में ही जाएगा, एज इट इज इट विल गो बैक. दैट इज व्हाट इज रिफ्लेक्शन, राइट? What decides the amount of reflection? It is the albedo which will decide the amount of reflection. The property of the material which will decide the amount of reflected part is what we call it as albedo. Albedo is a ratio. Albedo is basically ratio. It is the ratio of reflected radiation divided by incoming radiation. It is the ratio of reflected radiation divided by incoming radiation. Let's say 100 units are incoming. In that 50 part is reflected and 50 part is observed. What is albedo of this surface? 1 by 2, 0.5 or 50%. In terms of percentage, it is 50%. If this surface reflects 90%, albedo is 90%. If this surface reflects only 10%, albedo is 10%. So basically how much of incoming radiation is reflected back, that is what we call it as albedo. It is also called as reflection coefficient. इसको बोलते हैं reflection coefficient. What is the basic nature of the surface which will decide the albedo? How bright or how dark the surface is. How bright or how dark. Bright surface reflects more light, dark surface absorbs more light. That is what is black and white. So nature में जो perfect black होता है, black hole मान लो, why it is called as black hole? Because it will not let even the light to escape. पूरा black दिखता है, right? A perfect black is a surface which absorbs 100% of incoming radiation. And it has zero albedo. A perfect white is zero absorption, 100% reflection. In nature there is no perfect black, perfect white. कोई भी 100% नहीं होता है. It is in between. Okay, the brightest surface which we see on the surface of Earth, which is capable of reflecting as it is snow covered, freshly covered with snow. जिसका मैक्सिमम अल्बेडो रहता है, so that is around 95%. It's around 95%. The surface with lowest albedo, black soil, उससे भी ज्यादा lowest albedo रहता है freshly laid out road, asphalt road, जो tar road बोलते हैं ना, है ना, asphalt road. So जब freshly बनाते हैं तो पूरा तब तो dark रहता है. That is reflection is like we can say around 5% of albedo. उसका रहता है around 5% albedo. So in nature the albedo varies between these two parts. इसी के बीच में ही रहता है. So if you consider the earth as a whole including the atmosphere as well as the surface, what is the average albedo of earth? What is the average albedo of earth as a whole? मतलब entire earth का average albedo क्या है? How much? Be louder. 52 one answer, or 100 another answer, or 50 35 और 0 कोई है? ठीक है, 100 वाले बताइए क्यों 100 है? धीरे धीरे जाएगा तो वो रिफ्लेक्शन थोड़ी होगा. व्हाट इज रिफ्लेक्शन? एज इट इज वापस जाना है. एज इट इज कितना गया था आउट ऑफ 100? 35. सिंपल है. आउट ऑफ 100 35 इज रिफ्लेक्टेड बैक, 65 इज ऑब्जर्व्ड. दिस ऑब्जर्व्ड पार्ट इज नॉट albedo. Albedo refers only to the reflected part. It should go back as it is. अब्जॉर्ब होके री रिलीज होना, दैट इज नॉट अल्बेडो, है ना. Albedo is the reflected part. The average albedo of the entire earth as a whole is 35%. It is 35%. ठीक है. I'm talking as earth as a whole. If you talk only about the surface, that was the reflection by surface, right? Surface reflection कितना था? 2%. Simple. Write about this. Albedo is ratio between the reflected amount of solar radiation and the incoming solar radiation by the earth as a whole full stop. It is also called as reflection coefficient. It is also called as reflection coefficient. The average albedo of the earth, is equal to 35%. Is equal to 35%. So this is the comparison of albedo of different surfaces. So freshly laid asphalt around 4%, fresh snow around 80 to 90%. So rest it is in between. You have to remember this order. Value जरूरी नहीं है, order याद रखना है. Okay, write this order. Low to high or high to low, जैसे भी हो. Soil without any kind of vegetation. सॉरी, थोड़ा सा ऐसे एलर्जी होता है कभी कभी. ठीक है. सो कोशिश करते हैं कंटिन्यू करने का. No, terrestrial radiation is not albedo. Terrestrial radiation is not part of a reflection, right? It is a part which has been released through absorption. Absorption होके release हुआ है ना. ठीक है. So this is one of the previous question asked. कौन सा? ऑप्शन सी. हाँ ठीक है. Prairie land refers to grasslands of temperate regions. ठीक है, आगे आएगा ये सब. So this is all about this topic. Let's move forward to the next topic, temperature. Temperature. So what is temperature? Temperature का मतलब क्या है? Degree of hotness. Degree of hotness or coldness is called as temperature. How hot or how cold a body is. What is the lowest possible temperature? It is not infinite. बताइए साइंस वाले. No, I'm saying lowest possible temperature anywhere. Minus 273. That is what is absolute zero, 0 Kelvin. ठीक है. The temperature on the surface of Earth varies from one place to another. So near to the tropical region we have high temperatures. Near to the polar regions we have low temperatures. In between we have moderate temperatures. The tropical regions with high temperature is called as torrid zone. इसको बोलते हैं torrid zone. Polar regions with low temperature is called as frigid zone. In between we have temperate zone. So the rough division is based on tropics: Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle. The region between the tropics is tropical region. Then what is subtropics? Beyond the tropics up to 35 degrees Celsius, 35 degrees north and south, that is subtropics. You can say 25 to 35 तक जो region है, that is subtropics. Beyond 35 up to 65, it is temperate regions. It is called as temperate regions. 65 के ऊपर polar region. The temperature varies from tropical to subtropical to temperate to polar regions. Right? So there are various factors which will decide the temperature of a particular place. एक factor तो हमने बहुत पहले से ही पढ़ लिया season के time में, the angle of incidence. That is the most important factor, right? Angle of incidence, length of the day, ये decide करता है how much temperature a particular season is. The torrid zone within the tropics, it is usually higher in temperature range between summers and winters. If you compare the winter temperature of this zone with other zones, still this zone has a higher temperature. The winter temperature of torrid zone, winter temperature of temperate zone, winter temperature of frigid zone. Still torrid zone has a higher temperature. Summer temperature भी इसी का ही highest रहता है. Frigid zone, very very cold, totally covered with ice, we can say. In between, it is said that it is moderate. बोलते कौन बोलते हैं? यही लोग बोलते हैं. वो खुद लोग, मतलब जो यूरोप में जो भी कंट्रीज है, वेस्टर्न यूरोप, these are the countries which call themselves to be the temperate countries. Okay, जैसे हमारे यहाँ तो moderate temperature रहता है, it is not too hot, not too cold. So you go there during the winter, समझ आएगा. They will not even come out. Moderate कैसे हुआ? Okay, totally covered with ice, snow. And इसके अलावा they also equate the the intellectual development with temperature. That is how they used to control their colonies, right? They used to say colonies जो भी है ट्रॉपिकल रीजन है, हाई टेम्परेचर रहता है, यहाँ पर तो इतना पसीना निकलता है, ये सारा दिमाग ही निकल जाता है इसमें. तो कुछ भी बोलते हैं. सो दे यूज्ड टू से हमारे यहाँ तो मॉडरेट टेम्परेचर रहता है, इतना हॉट नहीं रहेगा, सो इसलिए लाइक वी आर मोर इंटेलेक्चुअली डेवलप्ड. सो दे यूज्ड टू कंट्रोल. ठीक है, सो इसलिए इसका नाम टेम्परेट रख दिया. सो खुद रख दिया टेम्परेट जोन. सो दैट रेफर्स टू मॉडरेट टेम्परेचर्स. ठीक है. सो नीचे है टॉरिड जोन. सो व्हाट फैक्टर्स विल डिसाइड द टेम्परेचर ऑफ एनी पर्टिकुलर प्लेस? बताइए, ये तो पता है आपको. इंटेंसिटी ऑफ सनलाइट, देन अल्टीट्यूड, लैटिट्यूड, डिस्टेंस फ्रॉम सी. वेरी गुड. ठीक है. हाँ, स्पीड ऑफ एयर क्या है? इसको बोलते हैं विंड्स, ऐसे टर्म. ऐसे टर्म इसलिए रखा है ना, विंड्स. ठीक है. और एक तो हमने ऑलरेडी डिस्कस कर लिया, इंसुलेशन. Insulation is the most important factor which will decide the temperature of a place. Insulation depends upon 3 factors. बताइए. Transparency of atmosphere, length of the day, latitude. So first factor. उसके पहले एक लाइन लिखो. What is temperature? The degree of hotness or coldness the degree of hotness or coldness of a surface is called as temperature. उसके नीचे factors affecting temperature. First one, insulation. Insulation in turn depends on transparency of atmosphere, then latitude, and then length of the day. So based on these factors, insolation कहां पर ज्यादा होता है? Equator. Equator receives higher insolation. I mean the insolation received per unit area, of course. So but still equator will not experience the highest temperature across the latitudes. If you measure the temperature across the latitudes, it is not the equator which will have the highest temperatures. Highest temperatures are experienced at subtropics. Subtropics refers to 30 region, 30 degrees north and south, उसी को ही बोलते हैं subtropics. Why? Tilt के वजह से only for a short period of time the sun rays fall vertically over there. Summer में ही होता है ना, वो भी 1-2 महीने के लिए, बाकी 10 महीने तो नीचे आता है. If you take the average of the sunlight falling, मतलब जिस एंगल में गिरेगा, एवरेज लिया तो इक्वेटर में ही सबसे ज्यादा होता है. नो, नॉट बिकॉज ऑफ दैट. इक्वेटर से ज्यादा और नीचे वाले लैटिट्यूड्स में है द ओशंस एंड लैंड मास, बिकॉज ऑफ क्लाउड्स. द इक्वेटोरियल रीजन्स एक्सपीरियंसेस क्लाउड्स डेली, वहां पर डेली बारिश होता है. इक्वेटोरियल रीजन्स एक्सपीरियंसेस रेनफॉल ऑन डेली बेसिस थ्रू आउट द ईयर. डेली देयर इज प्रेसिपिटेशन. ओके, इसका कारण तो आगे जाके समझ आएगा, सो डिटेल में बात करेंगे डिफरेंट टाइप्स ऑफ प्रेसिपिटेशन. इक्वेटोरियल रीजन रिसीव्स डेली बेसिस में कन्वेक्शनल प्रेसिपिटेशन. कन्वेक्शन के साथ में, कन्वेक्शन के थ्रू प्रेसिपिटेशन होता है. बिकॉज ऑफ दिस द इक्वेटोरियल रीजन will not experience highest temperature. Even though the angle of incidence is almost vertical throughout the year, the actual high temperature is not experienced at the surface because of cloud coverage. It will reduce some amount of insolation reaching the surface. However, at subtropics, 30 degrees north and south, there are not much cloud cover. वहाँ पर ज़्यादा cloud cover होता ही नहीं है, क्योंकि वहाँ पर ज़्यादा बारिश होता ही नहीं. उसका भी कारण हम डिटेल में डिस्कस करेंगे. 30 डिग्रीज में क्यों बारिश नहीं होता है. 30 डिग्रीज अक्रॉस एनी पार्ट ऑफ द सरफेस दे डू नॉट रिसीव मच ऑफ प्रेसिपिटेशन. वहाँ पर डेजर्ट्स होते हैं, बहुत ज़्यादा डेजर्ट्स होते हैं, हॉट डेजर्ट्स. देयर आर डिफरेंट रीजंस बिहाइंड दैट. ओवरऑल उसके वजह से, बिकॉज ऑफ दैट, देयर इज नॉट मच प्रेसिपिटेशन, देयर इज नॉट मच ऑफ क्लाउड फॉर्मेशन. सो बिकॉज ऑफ लैक ऑफ क्लाउड फॉर्मेशन देयर इज मतलब ज्यादा इंसुलेशन, जितना इंसुलेशन मैक्सिमम रिसीव होगा वो मैक्सिमम वहां पर रिसीव होता है. ठीक है. सो एट दिस पॉइंट, इवन दो सन्स रेज आर वर्टिकल, even though sun's rays are vertical along the equator, throughout the year, the equator will not have maximum temperature due to cloud cover. Due to cloud cover. ठीक है, that is one important factor. एक और फैक्टर भी हमने डिस्कस कर लिया, अल्बेडो ऑफ ए पर्टिकुलर प्लेस. अल्बेडो ऑल्सो डिसाइड्स द टेम्परेचर, बिकॉज जितना ज्यादा रिफ्लेक्शन होगा उतना कम ऑब्जर्वेशन होगा. कम ऑब्जर्वेशन है तो लोअर द टेम्परेचर. ठीक है. नेक्स्ट वन, अल्बेडो. सरफेस विथ हायर अल्बेडो reflects back more insolation resulting in less absorption of heat, causing lower temperature. So other than this, the most important factor is nature of the surface which is under consideration. मतलब कौन सी सरफेस का बात कर रहे हैं. So it can be a land surface or water surface. Both behave differently. So there is a term called as specific heat. Have you heard of this? Specific heat. What is specific heat of any surface or substance? जिसको पता है वो बताएं, मतलब प्रॉपरली पूरा एग्जैक्ट जिसको पता है बताइए. गुड. Let's say we are talking about a particular land surface and its present temperature is 20 degrees Celsius. You want to increase the temperature, what you have to do? We have to supply heat or energy. You have to supply heat or energy. It is the amount of heat you have to supply in order to raise the temperature by 1 degree Celsius. कितना हीट सप्लाई किया तो इसका टेम्परेचर 20 से 21 हो जाएगा या 21 से 22 हो जाएगा, 22 से 23 हो जाएगा. The amount of heat required to raise the temperature of the surface by 1 degree Celsius is the specific heat of this surface. ये तो यूनिवर्सल नहीं है. It depends, it varies from one surface to another surface. The specific heat of this surface is the amount of heat required to rise the temperature by 1 degree Celsius. Specific heat of surface is lower than the specific heat of water body, which is higher. मतलब if you talk about the same surface, मतलब same surface with same temperature, यहाँ पर भी 20 degree Celsius है, यहाँ पर भी 20 degree Celsius है. You're talking about this is land surface, this is water surface. There is a water body here, there is a land, and both are at 20 degree Celsius. You want to increase this from 20 to 21 degree Celsius. If you have to supply a h amount of heat, here you have to supply more than h amount of heat. मतलब यहां पर तो बहुत ज्यादा हीट सप्लाई करना है तभी वो टेम्परेचर 1 डिग्री राइज होगा. दैट मीन्स इट्स स्पेसिफिक हीट इज हायर. अगर कोई दूसरा ऐसे वाला सरफेस पकड़ो जिसका स्पेसिफिक हीट लोअर है, even with supplying very less amount of heat, its temperature rises fast. So you're getting the implication of specific heat. Specific heat decide करता है what is the rate at which the temperature is rising. The same amount of insolation may fall, but the temperature rise will be different at different surface depending upon the specific heat of that particular surface. That is why the land gets heated up faster and the water body will not get heated up faster. है ना, इसी की वजह से ही है. Any land surface will get heated up faster. Water body will not get heated up faster. अगर heat up हो सकता है तो cool down भी होगा. It applies in opposite direction also. The amount of heat you need to remove in order to decrease the temperature from 21 to 20 degrees Celsius, वो भी specific heat है. अगर यहां पर सप्लाई कर रहे हैं यहां पर तो निकाल सकते हैं ना. The amount of heat which is lost by a surface in order to decrease its temperature by 1 degree Celsius. That is why the land cools down faster, whereas the water body cools down slower, because the specific heat of the specific heat of surface is lower than the specific heat of water. Okay, this is the basic difference between the land surface and water surface. Land surface has a higher specific heat. That means, land surface has a lower specific heat. That means you need to supply less amount of heat to rise its temperature than compared to water body, which has a higher specific heat. You need to supply more amount of heat to rise its temperature. Land heats up faster and cools down faster. Water body heats up slower and cools down slower. So that is why in any particular season you compare the continents and oceans along the same latitude. Along the same latitude you compare the land and ocean. For example, you take a place peninsular India, Bangalore मान लो. Same latitude, Bay of Bengal में एक location पकड़ो. On any day in summer, the land is hotter than the same point along the same latitude in Bay of Bengal. Insolation तो same ही है, latitude same है तो insolation भी same रहेगा. Duration of that insolation is also same. Length of the day is also same. Same amount of insolation falls on both the surface. One on land, one on water body, but here the land's temperature is higher than the water body. Water body usually remains cooler than the land surface. That is the implication of specific heat, having different specific heat. Now, इसके वजह से एक और implication भी है. all the places which are located near to the water body will also have the same impact. Okay, coastal locations, for example, the places which are near to a large water body, coastal locations, they will also come under the moderation effect of these water bodies. The water body, big water body, will not let this place to rise its temperature faster or cool down its temperature faster than a place which is located deep interior in the continent. It is totally surrounded by continents, water body से बहुत दूर है, it will get heated up faster and it will also cool down faster. Best example is Delhi. In summer we experience very high temperature, 45-46 degrees Celsius. In winter, तो अभी तो पता चल रहा है, so the temperature has gone up to 2 degrees Celsius. So why there is so much of variation? Because we are very away from ocean, water body से बहुत दूर है. So then compared to Chennai or Mumbai or Kolkata, the summer is also not hotter, the winter is also not colder. The maximum temperature of Mumbai may be summer में अभी थोड़ा बहुत ज़्यादा pollution की वजह से और मान लो 35 तक जाएगा. ओके, सो मान लो 35 तक जाएगा, विंटर में तो मैक्सिमम 20 तक ही जाएगा, 20-15 मान लो, बहुत कम हो गया तो इट विल नॉट बी टू एक्सट्रीम लाइक दिस. इज इट क्लियर? दिस इफेक्ट इज कॉल्ड एज कॉन्टिनेंटैलिटी. इसको बोलते हैं कॉन्टिनेंटैलिटी. द डीपर यू आर लोकेटेड विद इन द कॉन्टिनेंट, जितना अंदर कॉन्टिनेंट के अंदर जाओगे अवे फ्रॉम द ओशंस, द टेम्परेचर राइजेस फास्टर एंड कूल्स डाउन फास्टर. ठीक है, so write about this. Nature of the surface, next point. Earth behaves differently depending on specific heat of surface. Full stop. The land surface with lower specific heat heats up more rapidly and intensely than water surface. Stop. Also, land cools rapidly. Next point, distance from the sea. Or continentality. The locations which are in interior of continent experience higher range of temperatures than coastal locations. Example, Delhi experiences hotter summer and colder winters. Delhi experiences hotter summer and colder winters than Mumbai. So मतलब wherever there are more land, the land का impact है कि it gets hotter fast and it also cools down fast. Oceans का ऐसा है कि it will not get heated up fast, it will not cool down also fast. So this also has an implication on the global distribution of temperature. If you see the global distribution of the continents right now, in the northern hemisphere there is more land and less water than in the southern hemisphere. We have more water surface and less land surface, है ना. southern hemisphere का देखो, southern hemisphere में तो land का part तो बहुत कम है. northern hemisphere has more land and less water. So that means the extremes of temperature is more in the northern hemisphere. Which hemisphere experiences hottest summer? Northern hemisphere. Which hemisphere experiences coldest winters? But still the coldest place on the surface of earth is southern hemisphere. Why? Because there is Antarctica here. ओके अंटार्कटिका तो बहुत कोल्ड रहता है इसलिए, अदरवाइज तो नॉर्थर्न हेमिस्फीयर में ही होगा. On the land, if you remove Antarctica from the picture, anywhere on the other continents, it should be the northern hemisphere because there is a large expanse of land. The summers and winters in the southern hemisphere, they are not as extreme as the summers and winters of northern hemisphere. यहाँ पर तो इतना ज़्यादा extreme नहीं होता है. So that is depend upon the distribution of land and ocean. Is that right? At this point, distribution of continents. Northern hemisphere factors में next factor, distribution of continents. Northern hemisphere with more proportion of land than oceans, experience higher range of temperature. Northern hemisphere with more proportion of land than oceans experience higher range of temperature than southern hemisphere with more water surface. With more water surface. एक और फैक्टर भी हमने ऑलरेडी डिस्कस कर लिया, अल्टीट्यूड. हाउ अल्टीट्यूड वेरी, मतलब इन टर्म्स ऑफ टेम्परेचर कैसे होता है. इंक्रीज द अल्टीट्यूड, टेम्परेचर डिक्रीजेस, नॉर्मल लैब सेट. एट दिस नेक्स्ट फैक्टर अल्टीट्यूड, टेम्परेचर डिक्रीजेस विथ इंक्रीज इन अल्टीट्यूड. इसके साथ में दो और फैक्टर्स है, एक है विंड्स, अनदर वन इज ओशन करंट्स. विंड्स, व्हाट एग्जैक्टली आर विंड्स? विंड इज बेसिकली एयर इन मोशन. ठीक है, एयर इन मोशन इज कॉल्ड एज विंड्स. व्हेन एयर मूव्स फ्रॉम वन प्लेस टू अनदर, इट इज कॉल्ड एज विंड. So when winds are there, when winds move from one place to another, it helps in distribution of temperature. Winds coming from hotter region carries that heat and distributes to the other regions, colder regions. Winds coming from colder regions are very cold and will reduce the temperature in its destination. It helps in this distribution of heat. तो हमने तो देखा था कि there is torrid zone, temperate zone, frigid zone. Here the temperature is higher, here it is moderate, here it is low. यहां पर तो but the surface re-radiates, it releases radiation from everywhere. हर जगह में तो रिलीज करता ही है. यहां पर ज्यादा इनकमिंग है, यहां पर कम इनकमिंग है. बैलेंस कैसे होगा? थ्रू विंड्स. One is winds, which help in distribution of higher heat in the tropical region to the polar region. Second one is ocean currents. What exactly are ocean currents? Ocean currents are like fast and strong movement of ocean water in a particular direction. ओशन करंट्स के बारे में हम बहुत डिटेल में बात करेंगे, ओशनोग्राफी में पूरा टॉपिक है, ठीक है. अभी के लिए इतना रखो क्योंकि तब तक तो बहुत बार आएगा ओशन करंट्स. आई विल वेरी ब्रीफली टेल यू व्हाट इज ओशन करंट्स. ओशन करंट्स आर लाइक रिवर्स इनसाइड ओशंस. Okay, so they are almost like rivers inside the oceans only. There is a strong and continuous flow of water in a particular region and particular direction within the oceans. Oceans के अंदर ही ये मिलता है. For example, यहाँ पर if you go along the eastern coast of USA, the water continuously flows in this direction and that is warm water. If you come towards the western coast of Europe, यहाँ पर भी warm water मिलता है. So like that there are fixed patterns of movement of currents, movement of water in the oceans. That is what we call as ocean currents. वो कैसे होता है, क्यों होता है, किस पैटर्न में होगा, किस डायरेक्शन में होगा, what are the types, बहुत डिटेल में बात करेंगे, ठीक है. So these ocean currents as they move from one place to another, it will also help in distribution of heat. The ocean currents coming from the tropical region, it carries the heat from the tropical region and distributes it to the polar region. In the same way, there are also some ocean currents coming from the polar region. It carries cold water and it will reduce the temperature here. ठीक है. Ocean currents also help in distribution of heat. ये दो point add कर देना. So next one, winds. They transport temperatures prevailing in one area to another. Temperature prevailing in one area to another. Example, planetary winds. Next, ocean currents. They transport warm water from tropics to polar regions and vice versa. Helping in global distribution of temperatures. Helping in global distribution of temperatures. Okay. So in the next class, let's talk about the distribution of temperature across the globe, and we'll also talk about pressure and winds. Thank you.